Okay, this is chapter 3, and this is on probability. And a couple sections of this chapter are pretty difficult. In fact, some of the sections, like sections 3.2, 3.3, and 3.4, are probably what I would consider the most difficult in the book. But 3.1, the beginning section, is pretty easy, not too bad, and it goes over some basic probability rules. First rule is that the probability of some event, E, is equal to the frequency over the number of possible outcomes. This could be an example like, for example, what is the probability of randomly selecting a female from the class that you're in? Well, we would write that the probability of a female, or probability of F, equals the total number of females in your class. And I don't know how many females are in your class, but let's say there was 10, and the total number of students, it would be out of the total number of students, and let's say the total number of students would be 25. So we would just write this as 10 over 25. Now, if you have any fraction like this, then you should reduce it. 5 goes into 10 2 times, and 5 goes into 25 5 times, so we could say 2/5. That would be a fine answer, or we could write our answer as a decimal if we wanted to. Well, 2/5 is the same as 4/10, or 0.4. So that would be a fine answer. Or we could even write the answer as a percentage. 0.4 is the same as 40%. So there's a 40% chance that you would randomly select a female from this class of 25 students, where 10 are females. So most of the questions, or almost all the questions, in fact I think all the questions on the test are multiple choice, so that you would know what form to put your answer in. You would just look to see if the answers are written with percentages or in decimals. So all those answers are fine. You should also know a few facts about probabilities. This says that the sum of the probabilities for all the possible events always add up to 100%. And we can write this as the following. Summation, this is a capital sigma, it's the Greek letter capital sigma, which is used for summation. This means if we add up, this little symbol means add up, if we add up all the probabilities, we should get 1, or in other words, 100%. So in other words, back on this problem, there's only 2 possible outcomes for students in your class when you look at gender. That's either female or male. So if we know that 40% of the class is female, then we know that 60% of the class is male, because the probabilities have to add up to 100%. So 100% minus 40% is 60%. So the total number of the probability of randomly selecting a male must be 60%. So that's how that helps in doing some problems. Also realize that a probability is always between 0 and 1, or we can write this as in other words, the probability of an event is somewhere between 0 and 1, less than or equal to 1, or greater than or equal to 0. Or as in terms of percentages, the probability of some event is greater than or equal to 0, or less than or equal to 100%. Okay, now you can have percentages, like something may be marked up at a grocery store or something 200%, but a probability cannot be greater than 100%. For example, if it is raining out right now, and I say what is the probability that it is raining, then the answer would be 100%. It's not a 1,000% chance of this like you hear people say sometimes. Now if it is raining out right now, and I say what's the probability it is not raining, then that probability would be 0. There's a 0% chance that it is not raining if it is raining out. But generally, your probabilities are somewhere between 0 and 1, but they could be, in fact, 0 and they could be 1, but they can't be negative. Okay, you can't have a negative probability of something, and you can't have greater than 100% chance of something. This is an important concept here, the probability of not selecting something, which we could write with a bar over top of that variable, or a hash mark, and I believe your book uses the hash mark, so I'll get rid of this notation here, right there. So the probability of not selecting a female, which we could write as the probability of F with a little slash mark after it, is equal to 1 minus the probability of female. So in other words, the probability of male, not being female, is male, is equal to 1 minus the probability of being female. So referring back to our last problem that we were dealing with the probability of selecting a female from the class, for our particular problem, the probability of randomly selecting a person that is not female is 1 minus the probability of selecting somebody that is female, which earlier we found out was 0.4, and 1 minus 0.4 is 0.6, or I like to put a 0 there so you can see the decimal point better, 0.6, which is the same as 60%. Okay? We could generalize this idea here and say the probability that an event doesn't happen, okay, and I should maybe say that with a hash mark right there instead of the bar over top, because your book uses the little slash mark like this right here to mean not. The probability of not an event not happening, is equal to 1 minus the probability that the event does happen. And we'll do the next video and we'll start to go over things like sample space and outcome and event in the next video.